Okay, this is the second day of section 5.2, verifying trig identities. This time we're going to be looking at cofunctions and even and odd. So with number one, what we're going to look at is this tangent of pi over 2 minus x. And you should be familiar with this. It's one of our cofunctions, and we know that that is also equal to cotangent of x. So I'm just going to substitute that in times secant of x to equal cosecant of x. Now rewriting this back as sine and cosine, I know that cotangent is cosine x over sine x. Secant is 1 over cosine x equals cosecant x. Can't forget the other side. I can simplify this because the cosines are going to go away, and that leaves me with the 1 over sine, which is cosecant x. This one is quick and simple. Okay? So that's the first one. Second one, same idea. I want the cotangent squared of pi over 2 minus x. The cofunction of cotangent is tangent, so that becomes tangent squared of x plus 1 equals secant squared x. Well, I know that tangent squared x plus 1, that's one of my identities. Hey, we're moving along pretty fast. And that is equal to secant squared, which is equal to what we're looking for. So these first two examples went by really fast because we're used to the cofunctions. We've been working with them for a while, but we've not seen them in a proof as of yet. So again, if you see a cofunction, you can substitute that cofunction in to kind of help things look a little bit better. Now let's get to the other parts, 3 and 4. 3 and 4 deal with even and odd, and I'm going to talk about that over here. Our even function is cosine. And so what happens is if I have cosine of negative theta, that equals just the cosine of theta. Because the negative theta is just a reflection over the x-axis, and cosine doesn't change reflecting over the x-axis because the x value stays the same. Sine is an odd function. The sine of negative theta becomes negative sine theta. Again, the same thing, looking at the reflection over the x-axis because we have that negative theta, we're going clockwise. Sine values change. When you reflect over the x-axis, the sign changes from either positive to negative, and so forth. These are going to become very handy for what we're going to work on here. So if I have cosecant of negative x, well, cosecant is the reciprocal for sine, so I'm just going to flip that one over. So it becomes sine to negative x. And you can do this there's a couple different ways of doing it. This is the way I'm going to do. So I'm just going to leave that negative x there. And secant is 1 over cosine of negative x. And I want it to equal negative cotangent of x. Now if I flip my bottom fraction over, I'm going to end up with the cosine of negative x over the sine of negative x equals negative cotangent x. And we're almost done. If you remember what I wrote over to the side, cosine of negative x is just the same as cosine of x. Sine of negative x is negative sine x to equal negative cotangent of x. And now I see my cosine over sine, and I see my negative out in front, and I can rewrite that as negative cotangent of x equals negative cotangent of x. Okay, so that's number 3. Let's move on to number 4. Looking at number 4, I have the cosine of negative x over 1 plus sine of negative, or excuse me, not negative x, negative theta plus over 1 plus sine of negative theta equals secant theta plus tangent theta. Now looking at this, I'm going to move those negatives, and I'm going to get cosine of theta over 1 minus sine of theta equals secant theta plus tangent theta. And if I just kind of glance at my right side, both secant and tangent have cosine in the denominator. So I need to figure out a way of getting a cosine in the denominator. So looking at this, probably the best way to do it is I'm going to multiply by the conjugate of my denominator. So I'm going to multiply the top and the bottom by 1 plus sine theta and 1 plus sine theta. And what that's going to give me is in my numerator, I'm going to have the cosine of theta times 1 plus sine theta, and I'm not going to distribute yet, over 1 plus sine theta times 1 minus sine theta, so that's 1 minus sine squared theta, equals that secant theta plus tangent theta. Now I can substitute cosine squared theta for my denominator. And now I have that cosine in my denominator that I want. And all I have to do is simplify. So crossing off the cosines, I now have 1 plus sine theta over the cosine of theta equals secant theta plus tangent theta. And you should see where we're going here. Now, split this. I have 1 over cosine, which is secant theta, plus sine over cosine. So I can have that as 2 fractions, and that gives me my tangent theta that I wanted. Okay, so that's it for the examples for concluding 5.2. If you have questions, make sure you bring them to class.